sorry for the connection issue. So, hello everyone. So I'm Jerry Liu from the AAAI Education Group. Today I'm very excited to share about some cool stuff we developed in TAL. So my talk today is AI, the next step for education, tech innovation, making our classrooms smarter. So first I want to spend a minute to introduce TAL. TAL is short for Tomorrow Advancing Life. So we are one of the largest leading companies in China. Right now we are expanding our market to US. So we have a research center in Silicon Valley, and also we have a kind of a learning center in Silicon Valley too. So we are recruiting students in Silicon Valley. Okay. So when I think about the education, the first thing pop up in my head is about classrooms. That's the thing I stay probably half of my life in the classroom. So I think one way to characterize the classroom is either offline or online. So recently, because of the development of internet, because of the 4G and the 5G, so a lot of learning is conducted online. So there are various types of learning forms, even for online. For example, maybe 5,000 of students taking the class together online, and they are watching the online streaming of the very famous teachers. That's one way to learn knowledge. And another way is that students just watching their mobile, and there are some video kind of animations and all the stuff, or even MOOC. Right. So there are a lot of forms of classrooms. And so I'm from computer science, when we do AI, all the stuff, the first thing I thought about is about the data. So in the classroom, there are a lot of data generated every day in the classroom, and those data are multimodal data. Those data involve language, which is the text-based stuff, and also visual stuff, the video or images, and also the vocal information, which is the speech stuff. So when we build the AI application, we have to combine all this data from different modalities together to make sure the AI can work. So this is a picture I think about what the data can happen in the classroom. So I can split the data into 3 phases: pre-class, in-class, and post-class. And also these data are generated by different people. Because in the classroom, we have instructor and student, that is kind of for sure. Everyone agree with that. But there are a third type of kind of people. So I call the administrator here. Those people do some negotiations with students, with their parents. So you can think of a very simple scenarios. When a student have a class when a student has a class, there are one person called their parents saying, "Oh, this is your performance of your kids, and he doesn't speak too much in the class," and all the stuff, all those negotiations, those kind of service. These people also generate kind of a bunch of useful data. So, and also, for example, we can look some blocks here. So, for example, for in-class, the voice interactions. So nowadays we give the teacher a bunch of we call it intelligent device, but those kind of cheap things. For example, the teacher can use some kind of cool PowerPoint to have some voice interaction with the students. And also the teacher can give students digital responders. So using the digital responder, students can press A, B, C, D, and to have kind of the live choice stuff. And also for the post-class, the instructor will give the class reports. Students have to finish their homework and assignment. And for those administrators, as I mentioned, they do the follow-ups with the parents, and they provide the feedback to the teachers. So all this data are generated every day. So when I think about AI and machine learning, all the stuff, I have to think about how to use all those data. So I split the whole process into 3 parts. The first part is collect. How do we collect data? When we do all the AI machine learning stuff in standard internet companies, like when you do search, when you do recommendation, when you do advertising, the data collection is not a problem because you are surfing on the internet. You click what you want, you click what you like, and you purchase all the stuff. The data are collected automatically. But when we do AI for classrooms, the data collection is a big issue. You can think of we have a building of 20 classrooms, and at every minute we take the recording of that classroom. For AI researchers, we want the data as good as possible, right? So we can record the video in a very high resolution. It turns out after an hour, you have, let's say, 3 gigabytes of videos, right? And you have 20 classrooms. That's a huge amount of data. How do you pass that data from that building to our backend? It's a trouble because the internet speed is not that good. If you upload those videos during the class, it may kind of have a conflict with the teacher because the teacher is also using the internet to having the class. So collecting those data is very difficult. Another thing is when we do AI, we need the labels. We need accurate labels. But if you think about the data we collect, it's just a class recordings. There's no label for them. It's also different from when you do recommendation on the stuff. When you do recommendations, you just predict what you like and what you purchase. And data you collect is also what you purchase. So that's the same thing. But for the data here, we just have classroom data. There's no label for us. Right? So this is the first part, is the collection. The second part, once we have the data, once we kind of pre-processing all the data, we do the AI, all the machine learning stuff, and we go to the assessment part. So we use data to kind of analyze both the student and the teachers. We want to understand if the quality of the class is good. As just mentioned, you do the interview for the teacher, right? So 2 teachers just use the direct interactions, the direct instructions to those students. This is something not the way we want, right? And we have a similar problem. We want to use AI to detect those kind of, let's call it the misbehaviors or something like that. Right? So we want to use the AI to kind of assess students and evaluate teachers. The next part is feedback. Once we do all the assessment, how do we provide feedback to both the student and teachers? So in AI, we have some dropout predictions, deep knowledge tracing, and all the stuff. And this become a loop. So I will show some applications we built. The first one is class quality assurance. So we have a platform looks like this. So it's an online 1v1 classrooms. So you see the instructor and the student. The student, both the instructor and student, they sit in their homes and they are having class online. Right? So that's the biggest part is about the materials or the slides. So this platform is like Uber at Airbnb. It's a marketplace. We bridging the student and the teacher into the common platform, and we do the matching. So once we do the matching, they have the class. Very similar to Uber and Airbnb. The supply side is the teacher, demand side is the student. So this helps us a lot because in China we are short of teachers, and people are willing to pay, but they cannot find good teachers. So we have that problem. And after each class, we have that 1 hour recording, and we will send that recording to the parents, and the parents can double check if the class is good or bad. But usually parents they don't have time. They just okay, let's just put the recording there. So for us, there's no way to make sure the class is really good. Also similar to Uber and Airbnb. Uber want to find those kind of bad drivers, and Airbnb want to find the bad hosts, and we want to find those unqualified teachers. So what we do here is we use AI to analyze those kind of videos. So I just show a very simple examples. So what we do is, first we want to check because each class is about one subject, it's either math, physics, and all stuff. We first want to check the subject keywords. For example, if it's a math class, if the teacher really talk about math. So that seems a stupid question, but sometimes it happens because teacher can talk about the video games with students for an hour. And the students think it's a very good class. The student will tell their parents, I still want that class. But it happens. So we want to make sure the teacher is really telling about the subject. And also, there are also some bad cases. For example, it's a 1 hour class. The teacher can just say, okay, let's work on this question. You think about 30 minutes. So in the next 30 minutes, it's totally silence. And teacher, they can leave and they can do whatever stuff. And then they come back to tell about the question, right? So it's definitely not a good class. So we'll check the silence. And the similar things is like banned words. So we don't want the teacher say, you are so stupid. We want to say that we want the teacher have patience. And other stuff is like we want the teacher keep ask questions to inspire the students, not just keep telling the knowledge. And also we want to, because our customers are the K-12 students, we want the teacher to teach the student how to take notes and how to summarize and all the stuff. So based on each dimensions, we have AI to detect or to make sure or analyze what's the real behavior in the class. And this, we also build it solutions so people can try and the companies can just use that solutions. And also this work is published in AAAI last year. Okay, so the second application I want to show is about spoken language proficiency assessment. So the idea is this. For the education in China, people think one big problem compared to US and other countries is the Chinese students, they don't speak. They can do very good job on homework, exam, but they don't know how to speak. And so we want to practice the oral language skills for K-12 students in China. The problem is no one gives them feedback. They can practice, but no one tells them how good it is. So in order to improve the Chinese K-12 students' spoken language proficiency, so we create a task we call the verbal fluency task. The task is a very simple math-related question. For example, like this. If we want to cut a loaf of bread into 20 pieces, how many cuts do you need? So we don't care about the answer. We ask students to tell the answer and tell their thinking process. It's like in HSI we do the think aloud, all the stuff. So we want the student to keep practicing all the stuff. So this verbal fluency task is very popular and all the parents like this stuff. But we don't have enough teacher to grade those tasks and give the student feedback. So that's why we built an AI or automated tool to do this assessment. I will show an example of this, the real task. When the real task happens, the student is doing the task and the parent takes the video of those students, and the video will upload to our backend. So we will do the analysis and do the assessment. Before we have the machine learning tools, so all the assessment, all of the video are graded by human teachers. But the real case is in Chinese, so I will just play a video, but people can get the feeling about that.
我们来看这一题是切法是小面包，就是说，你看这个是切了10下，再加上原来没切的这一段加1，那就是11段。这一题是我一共有20段，请问我切了几下呢？是说我一共有20段，减去没切的这一小块，那就是减1，20减1等于19下，那就是我一共切了19下。
Yeah, so we got all these video clips, and we want to give a comprehensive assessment on those clips. Okay, so the AI tool we built is we will analyze the clips from the 6 dimensions. The first dimension is the verbal fluency. If the student can say all the sentence fluently. The next one is the topic relevance. So why we have that one? Because we have a question you see before, right? To cut the loaf of bread. Sometimes the student will see something randomly. It is very fluent, but it's totally irrelevant to our questions. So we don't want our system to be fooled by the student. So we need to double check the topic relevance. That's why we have this second dimension. The third dimension is the coherence. It's more about the logic. So when students give a short paragraph of speech, so we want to make sure it's kind of logically coherent. The fourth one is vocal emotions. We want the student to kind of have the emotions to say that things. The fifth one is post interactions. This example doesn't have post, but sometimes the student just sit in their living room and the student they are doing kind of addressing the speech. They need to have some emotions. So we will also analyze using kind of video or image data. The last one is the vocabulary diversity. We want to encourage the students to use more. I mean, it's like the difficult words or the fancy words. Yeah. So this is our automatic tool to kind of assess the spoken language proficiency. Yeah. So there are a lot of machine learning models behind this stuff. So I don't want to go to too many details, because if people want to check details, people can see our papers. We have all the details there. And also, right now we have the Chinese versions. People can use WeChat to scan this code and to just experience and play with this stuff. Yeah. Okay, so the third one I want to show is about class activity detection. So what is class activity detection? The task is very simple. When you get a kind of a recording of a class, usually there are two types of people speaking in the class, the teacher and the student. And the first thing to understand the class is you have to separate which part is the teacher is saying and which part is the student are speaking. So there are, as I mentioned, there are many types of classroom. It is a very challenging problem, so we started from the 1v1 offline classroom. So I also took some pictures. This is the real 1v1 offline classrooms. So after each class, you have the recordings, and you want to use AI kind of to do the speaker role classifications. You want to know which part is the teacher talk, which part is student talk, which part is no voice or silence. So this is kind of turns out to be a very difficult task. People may think this is similar to a very classic speech problem we call the cocktail problem or the speaker derivations. Actually, they are different. So for the speaker derivation problem, is you know how many people join the meeting, and you know those people. Those people are fixed, and you want to assign those labels to different people. But here, you can think of, we want to have one model to classify many teachers and students. For example, in one classroom, the teacher's voice may be very similar to another classroom student. So we don't want to build we don't want to build one model for one classroom. We want to build a unified model for every classroom. So that's the challenging part. So here we propose a deep learning model we call the multimodal attention models. So here basically the idea is when the class happens, we have two subjects, the teacher and the student. One thing can distinguish these two is the content, because the content should be distinguishable. But if you just look at the content, the first thing you need to do the segment. You need to segment the entire class into small segments. If you just look at each segment individually, even you look at the text, it's difficult to tell the segment is from the teacher or student. So you have to do some sort of clustering first. You cut the recording into small pieces, and you do the clustering first using the voice, because the teacher's voice and student's voice are different. Once you do the clustering, and you combine all the tags, now those tags are kind of distinguishable, and you can do classifier using the tags, which means basically you have to use both the acoustic features and the text features to accomplish that task. So, and also we have extensive experiment and also the explanation about the model in our AAAI papers. Okay, so the fourth one I want to show is about the deep knowledge tracing. It's kind of knowledge tracing is a very classic task. So for people who don't know, it's basically like given the observation of interactions x0 to xt, it's kind of like a time series. All the past observations, taken by the student on a particular learning task. And the goal is to predict what's the next interaction, xt plus 1. So that's the standard knowledge tracing. So here is one example. So I steal this picture from the NIST paper 5 years ago. It's the first paper about the deep knowledge tracing by Stanford folks. So here you can see it's a matrix, right? It's a 6 by 50 matrix. The way how we read this matrix is it has 50 columns. It means the student kind of performed 50 tasks. And there are 6 different tasks. So that's why you have 6 rows. So, and for each task or each exercise, the task can be either correct or incorrect. So basically, for one student, you have a sequence length is 50, and you know the task is correct or incorrect. So that's kind of the time series that you have. And the goal is to predict what's the probability of different question for that student. So our idea is now you have the student interaction data, right? So you know which one is correct, which one is incorrect. But you don't fully utilize the data from the question itself. So we want to combine these two information to make it better. It's pretty much similar to the standard movie recommendations, right? You have all the ratings, all the stuff. It's more like interaction data. You have all the set information. Who is the actors? What's it about the movie and all the stuff. That's when it comes to the question part. Okay, so we build the question graph and we do the embeddings, and we use that information to help the knowledge tracing. Yeah. So this is kind of the framework picture from our papers. Okay. So I just show 4 of these kind of cool applications we built in Tao. When we build the application, I feel like it's very different from the standard AI in internet companies like search, recommendation, and advertising. You feel a lot of problems you never imagined. So I just summarized into 4 categories. The first one is small data. Small data, that means the volume is small. It means you don't have too many labels. And getting the label is very difficult. You do the annotations, you do the color sourcing, and you have high inconsistencies of those labels. The next one is heterogeneity. So those data, as I show the big tables, you have different type of data, and they are coming from different forms, either in papers, either in digital devices, or class recordings. And also the quality issue usually is very bad. Sometimes some pictures they show the curve. Those are when you do the OCR and all the stuff from the student handwriting is just terrible. And also the evaluation is very difficult. When even your AI makes the prediction, do the teacher or the people really buy in your predictions? Do they accept your work? So there are a lot of challenges. but I feel like the change makes people excited about this AI in education field. I think there are a lot of opportunity, at least for AI and CS folks. There are too many problems you never see in the standard AI and machine learning stuff. Yeah. This is all the reference we have. Yeah, thank you very much.
Thank you. Are there any questions?
In your classroom activity detection, do you need to also understand the speech from the people, or just know whether they're speaking or not?
Yeah, when we do the task, we need the automatic, the ASR, automatic speech recognition. You need to, because we want to use both the acoustic feature and the text feature to do the task. The way you get a text feature is you do the ASR transcription.
Pity, because there's a simple solution if you only need activity detection, which we found works pretty well, which is we give everybody throat mics, which are essentially a little collar that you wear. They're lousy for word detection. The ASR on throat mic doesn't work very well. But
exactly.
You put a voice activity detector on, it works great. So it's easy to tell who's speaking. And they have very high rejection ratios, so you won't get a common problem with headset mics when two people are talking to each other is my voice bounces off of your face into your microphone. So they're not so good at activity detection, but the throat mics are great. The other thing. Sorry, go ahead.
So we also investigating those kind of devices, and there are some noise cancellations for those devices. But the problem is so later on we want to have a solution for every class. So we can use that to collect data, but later on when we deploy the solution, we cannot ask every student and every teacher to kind of wear the Mac to having class every day. So people don't like that. The teacher rejected to wear the Mac to. The teacher is okay because we own those teachers, so we can kind of ask them to wear. But the students and the parents, they don't want their student to kind of wear their stuff.
Well, that's what our American classroom teachers said too. They said, if the parents find out that you're putting mics on our kids, I'm going to lose my job. So we had to clear it through the parents first. But the reason I like the throat mics is activity detection will actually get you a long ways towards detecting collaboration and a lot of other things. That's one. The other reason is that we found that when we put headset mics on the children, these are middle school students, they play with them. They put them in their mouths, they put them on top of their heads. They find them uncomfortable, so they put them around their necks. Whereas with the throat mics, they kind of forget they're there. And so we have many fewer problems with the throat mics. And they're cheap.
Yeah, it's about, I think we go to the manufacturer in Shenzhen, so I think it's about, it's less than $10.
Yep.
So two quick questions, and thank you for the great presentation. I'm interested if you're using a multimodal embedding space where you take each of the, since you have data from different modalities, you have voice, you have images, are you creating embeddings for each of those modalities separately, or are you trying to combine it into one space and then inference whatever head architecture on top of that?
So we did both. To be honest, we did both, and we just try which one works.
I'm interested. Can you
because
talk more?
sometimes the story or the idea is when you combine everything and you use those kind of combination, you get the best result. But in practice, sometimes it doesn't work. So, and then also another problem is for different modality, you need to also solve some problem. It's like alignment. You have to align, for example, speech and the video. You have to align them together. It's also very tough.
Another small question. So the platform obviously has a lot of benefit to it, some downside to it. From your perspective, what are the top thing that the students benefit from using it, and the thing that should be improved the most as of the platform that you're providing?
That's also a good question. So actually, I just show one part of the kind of the platform, which is kind of monitoring the teacher behaviors. The other part, actually, we have the other part is showing the change of the student. Well, so which means what we want to achieve is so usually when the student buy those kind of class, you buy it for a whole semester. Let's say you give me $1,000 and I will give you 50 classes, right? You take the class 1 week by week. So what we do is we want to say, okay, we cannot guarantee your grade will be improved after this 50 class. We cannot guarantee that. But what we can guarantee is your kid will be changed. So changed in a way that, for example, when the student go to the class, so maybe in the first 5 classes, they don't ask any question. They just note their notes. They just say, okay, thanks teacher, bye-bye, right? So they don't have no interaction with the teachers. And they don't know how to take notes and how to kind of summarize all the class. And we want to show is that maybe after 10 class or after 20 class, now your kids will ask the questions. They learn how to ask questions. They learn how to take notes. Right? So we just visualize all these kind of student behaviors week by week, and we can plot a chart and show those to parents and teachers. So you see, those are the behavior we think which is very good for students, and your kids change after a certain amount of class.
So is the standard is the criteria requirement standardized among all the users, or you can ask the parents to customize there? Because some parents say, I'm fine with my kids is silent. Or I don't want him to take notes, but I want him to improve his frequency of asking questions. Do you allow customer to customize their preference?
Yeah, that's a good question. So in that platform, we call the thing I just described. We call this kind of the new feature or the ideas of our platform. So which means we have put a lot of educators to study or to kind of to make sure which student behavior are those kind of key student behaviors, and we think these are very important. And you have to kind of buy in our logic first before you go to the class.
Yeah, since you're using knowledge tracing, I'm wondering to what extent you're using other learning analytics, clickstream, log file detection metrics like engagement, on-task detectors, off-task detectors, engaged off-task, boredom.
Yeah, that's a very difficult task. We haven't touched that too much because the students are very difficult to understand, to be honest. And the data is difficult to collect all the kind of data around this learning process. So we try to kind of the visual stuff first. We have a kind of visual classifier to detect the student is smell, confused, and all the stuff. But it turns out it doesn't work because it's no ground truth for confused. So it's very difficult. But I would like to know if there is a solution at all.
Okay, so if you have other questions for any of the presenters, you can ask during coffee. We have a half hour for coffee break, and we'll come back together for the paper poster session at 11. So thank you so much.
Yeah, and I think during the break, let's set up the posters, okay? So probably just inside the room.